This is section 1.4, equations of lines. So we do have a couple of forms here we're going to look at. The first one we kind of went over, it's slope-intercept form, where m is your slope. So whatever's in front of x is your slope. And b is your y-intercept. So when we're solving for equations or finding the equation of a line, we're generally going to put it in slope-intercept form. Another formula we're going to use to find these equations lines is called point slope. So if you have a point and you have the slope, you can find the equation of a line. So it's y minus y1 equals m times x minus x1. And we're gonna use these through section 1.4. All right, so the first two on the right, they're pretty straightforward. We have a slope of 2/3. And this line has a y-intercept of 5. So we need to write the equation of the line. And we can just use slope-intercept form. There's nothing to really calculate here. So it's y equals 2/3 x. 5 is positive, so we're going to put plus 5. The next one, we have a slope of -3 and a y-intercept of -5/2. So the equation of the line is y equals -3x minus, because it's a negative, 5/2. And that's what they want in MyMathLab. And I'm just gonna, you don't have to write this part down. I just want to show you real quick. So when you're in MyMathLab and there's a question and then you have the answer box, when you click in that answer box, you have a little box at the bottom that'll pop up. So if you need things like fraction bar down the line, if we need infinity, some special symbols, they'll be right there in the box. They have one where you can click more and see more symbols, but you really don't need to do that. Whatever you need is going to be in that box. And division bar, you can also just use the division symbol on your keypad on your computer and it will flip into a fraction. So you can just kind of play around with that if you want to. All right, so we need to find the equation line that goes through the point 4, -6. So that's x1, y1. And it has a slope of -2/3. The best way to memorize point slope is to write it each time that you use it, just like you do with the slope formula. And then from there, I'm going to plug in my values. So y minus y1, which is -6. My slope is -2/3. And then x minus x1, which is 4. Once you get this written down, there's a certain order you need to do things. And I'm telling you this because of the errors I see. So the first thing you need to deal with if you have any double negatives. Okay, I have one set of double negatives. That's going to make it positive or plus. You can have one set, you can have two sets, you can have no double negatives. Okay. Then after that, you're going to distribute. You're going to multiply that 2/3 times everything that's inside of parentheses. And then for the second part, we have -2/3 times -4. So I'm going to flip over to the calculator. Negative, and let's put in our fraction bar, times -4. So I have -2/3 times -4. You hit enter and it gives you the fraction and it reduces it, so you get a positive 8/3. From here, you have one more step. We need to move the 6 to the right to get y by itself. So we're going to subtract the 6. On the left side, the 6's cancel out and you're left with y. On the right side, we subtract the 6 from the 8/3 because neither one of those has a letter on it. So they are the same. I'm going to go back to the calculator. So I have 8/3. And it was -6. Not negative, but minus. And that gives me a negative or -10/3. Right? So that is the answer. And we're going to do several of these. So again, we're going to label that point. And we have a slope of 4. A reminder that this is a video, so if you need to stop it and catch up on the writing, you can do that. If you want to go ahead and try a question before I do it, you can try it on your own and then see how you do with it. All right. So y minus y1 equals m times x minus x1. All right. So again, the first thing I want you to deal with are any double negatives. So I do have one set. We're subtracting a -8, so that's going to become a plus. So y plus 8 was 4 times x minus 0. All right, so on the right side, we're going to distribute. We're going to multiply that 4. So 4 times x is 4x. And 4 times 0 is just 0, so we don't write plus 0. From there, I need to get y by itself. So the last thing I need to do is move the 8. And I don't subtract it from the 4x because the 4x has an x on it, but the 8 does not. On the left side, the 8's cancel out. And there is your answer. So that one was a little bit nicer. It depends on the problem. You may get ones with a bunch of fractions. You may get ones that have some nice numbers that are not in the form of a fraction. Let's look at a couple more. All right, we need to find an equation line that is a vertical line. All right, so vertical, and it goes through the point 9, -10. So it goes through this point. The vertical line is up and down. So the slope on that, if you remember back from section 1.3, the slope is undefined. So you can't put undefined in an equation. But if you look back at the notes, this crosses the x-axis at 9. So it's just x equals 9. Right, then we have one that has a horizontal line that goes through the point 5, -7. Horizontal like with the horizon, so that's going to be left to right. Let me put undefined on here for slope. And remember, if you need to add more notes than what I'm actually giving you, you need to write down what you need. to remember on how to do these problems. Okay, so it's not just what I write down, it's whatever else you need to write down, your own personal notes too. All right, so this one has a slope of 0. And we can put that in. If you remember that it's a special case, it's just y equals -7, that's fine. But if we put it in point slope, we can actually do that. And we have a set of double negatives, becomes a plus. And then on the right side, if I multiply both of those times 0, I just get 0. Anything times 0 is 0. Whether it's an x, because x just represents some number, and that number times 0 is going to be 0. Lastly, we need to get y by itself, so we're going to subtract 7 for both sides. So y equals -7. All right, this one has 2 points, so we're missing a slope. But is there a way I can find the slope? All right, so in 1-3, we went over how to find slope. So we're just going to have one more step before we finish this problem. I'm going to make the screen just a little bit bigger. So let's find the slope first. So y2 is 7 minus, let me, just a second, 1. X2 is 4 minus -2. I'm going to flip over to the calculator. And that's going to give me a +1 for my slope. Now from here, you can use either point. You just need one of the points and the slope. So we found the slope. And I'm going to use this point just because there's no negatives. That's why I'm choosing it, not for any other reason. If you use the other point, you're going to get different numbers in the beginning, but you'll work down to the same equation that we end up with. All right, so y minus y1 equals m times x minus x1. So I look at this, there's no double negatives, so I'm good on that. The next step is to distribute or multiply that 1 times everything inside parentheses. Anything times 1 is itself, so it's just x minus 4. We're solving for y, so I need to move that 7. I'm going to add it to the right. I'm adding the 7 to the -4 because neither one of those have a letter attached. The left side, the 7's cancel out. And let me flip over to my calculator. So if you're a little rusty on positive and negative numbers, you're going to do -4 plus 7. And that's going to give me a positive or +3. Same thing here, x1, y1, x2, y2. So let's find the slope first. I'm going to flip over to the calculator. Put this in. So -3 minus 5. So that's going to give me a slope of 0. Oops. Great. So we have the slope, and you can pick one of the points. Sorry about that. And I'm going to pick 5, 2, and I'm picking those particular points because everything's positive. You're less likely to make errors. But again, you can use the second point if you wanted to. So y minus y1 equals m times x minus x1. Point slope just requires one point in the slope. I'm looking for double negatives. I don't see any. So then I'm going to go on to distributing the 0 to everything on the right. Anything times 0 is 0. Still need to get y by itself, so I need to move the 2. I'm going to do the opposite. I'm going to add it to both sides. Those cancel out, and y is equal to positive 2. All right, this one's from a graph. Now, I took this image out of the textbook, but when you get in MyMathLab, I don't believe it labels the points. You have to figure out where they are on the grid. So I'm going to go ahead and label these. And again, the first thing we want to do is find the slope. So y2 minus y1 over x2 minus x1. Put this in the calculator. Let me double check. Hit enter, and I get a positive 3 for that slope. And then pick one point to use. Again, I want to use 413 because both of those are positive. And then our slope was 3. Let's put that in point slope. So y minus 13 equals 3 times x minus 4. I look for double negatives. I don't have any. So I'm going to go ahead and distribute the 3 to everything in the parentheses. So I have 3x. And if you need to, this is what the calculator is for. We have 3 times negative 4, okay, which gives me negative or minus 12. From there, I'm going to get y by itself, so I'm going to add 13 to both sides. The left side, the 13s cancel out. I'm left with y. And all right, I have 3x, and then I have negative 12 plus 13, which gives me a positive or plus 1. All right, so write the equation of the function. If the rate of change is negative 12, the initial value is 13. So think about what is the rate of change in the context of an equation. The rate of change is the what? The slope. And then let's look at the initial value. I'm going to graph it and you're going to tell me what it is. So when we look at this, the initial value is a positive 13. So at time 0, at the beginning, the initial value of something is 13. So what is that? What's special about that point? That is your y-intercept. So the y-intercept is equal to 13. So what is the equation of the line? It's y equals negative 12x plus 13. Let's look at another one. Rate of change is 7. So that is our slope. The initial value when we start is 23. So that is our y-intercept. That means the equation of that line is y equals 7x plus 23. All right, parallel and perpendicular lines. So let's look at parallel. What do we know about parallel lines? If we were to sketch them, we know they never touch. But there's two special things about them. One thing is they have the same slope. Because they're leaning the same way, the same incline. So the slope is the same. But they have different y-intercepts. Because if they had the same slope and the same y-intercept, they would be the same line. Here's an example, parallel lines, y equals, let's do 2/3 x plus 5, and y equals 2/3 x plus 1. So those lines, whatever's in front of x is your slope. So both the slopes are the same, but the y-intercepts are different. Let's move over to perpendicular lines. I don't know if anybody remembers from geometry. Perpendicular lines, they meet at a right angle. So visually, that's what they look like. But there is a special relationship between their slope. You may remember it, you may not. One of the things that's special about the slopes of perpendicular lines is they are opposite signs. And again, however, you need to make notes here for yourself. You need to do that. So one would be positive and one's going to be negative. And the other thing is they are reciprocals of one another, or the flip of a fraction. And these two lines are perpendicular. So the first one, the slope is negative 5/3 x. And whatever's going on with the y-intercept, it's irrelevant. It's independent of how to determine if the lines are perpendicular. So the slope of this first one is negative. The slope of the perpendicular line is going to be positive. You take 5/3 and you flip it, and you get 3/5. And then again, the y-intercept, you can do, it's irrelevant what that is. Okay. Now we're going to find equation of the lines, and this is probably going to be the most labor-intensive problems that you're going to have in this class. So we need to find an equation of line that passes through a point that's at -3, 7, and it's parallel to the line that they give us. So we need to take the equation of this line, and I need to find the slope. In order to find the slope, I need to solve for y. So I'm going to actually move the 3y to the right. It doesn't matter what side y is on as long as it's by itself. So those cancel out. I'm left with 2x minus 7 on the left. 0 minus 3y is a negative 3y. The last thing to get y by itself is divide each one of these by -3. So I have a -2/3 x, and then negative over negative is plus 7/3. Here, the -3's cancel out, and you're left with y. So we got y by itself. That's what we wanted. It doesn't have to be on the left side. It can be on the right. From here, we need the slope. So what is the slope? What's in front of x? That's -2/3. And since the lines are parallel, the slope is the same. So this is the actual slope we're going to use. And then we have a point that we're going to use. I didn't mean for that whole thing to. So it's going to be y minus y1 equals m, which is our slope, times x minus x1. So we're back to any kind of double negative. So we do have one set. That's going to become a plus. That's going to be x plus 3. From there, we're going to distribute, multiply that -2/3. So it's -2/3 x. Then I want to flip over to the calculator. So I have a -2/3 times 3, which gives me a -2 or -2. Still need to get y by itself, so I need to move the 7. I'm going to do that by adding it to both sides. They cancel out on the left. And then -2 plus 7, you can put that in your calculator if you need to. It's going to give me a positive or plus 5. Okay, let's do another one. And this one is also parallel. So we need to pull the slope out of here. This one's nice. It only has one step. We just need to move the 3x to the right to get y by itself. So it's -3x and 4 is positive, so we're going to put plus. And we don't add those together because one has an x on it and one does not. Our slope, whatever's in front of x, that's going to be -3. And it's parallel, so it's the same slope. We don't do anything to the slope. We're going to leave it. And then we have a point at 4, -6. Put it in point slope. So y minus y1 equals m times x minus x1. We have one set of double negatives on the left. So let's take care of those. That makes it a y plus 6. Please do not try to do multiple steps at a time. I've seen students try to do that and they make errors. So anytime I show you what seems like an extra step, It's because I see students make so many errors. Just stay with the process. Now from here again, we're going to distribute, we're going to multiply. So I have negative 3x. The negative 3 times negative 4 is going to give us a positive 12. And again, you can use your calculator for that if you need to. Still need to get y by itself, so we're going to subtract the 6 from both sides. Those go away and you're left with y. I have negative 3x, and then 12 minus 6 is a positive or plus 6. Maybe I think we just have 2 more. Oh, we don't. This is probably I think this is the longest section we have in this class. All right. So this one is perpendicular to the line. Let's start by putting the equation of this line in slope-intercept form. So we're going to solve for y. And again, since there's so much on the left, I'm just going to move the 4y to the right. And then on the left side, I'm left with x minus 10. Finally, to get y by itself, I divide each one of these by 4. So x over 4, there's an understood 1 here. So that's the same as 1/4 x. And we're not going to use the y-intercept. So you can just leave it like it is. You don't have to reduce it. All right, so the slope on this line is a positive 1/4. This perpendicular slope, we're going to change the sign. So we're going to make it negative. And when I flip it, I get 4 over 1, which is just 4. So the slope that we're going to use is the perpendicular slope, which is the opposite sign and the reciprocal. So it's going to be negative. Then we have a point. So let's plug that in point slope. So y minus y1 equals m times x minus x1. Now I don't have any double negatives, but if I look on the left, I have y minus 0, which is just y. From there, I'm going to distribute and multiply the negative 4. So it's negative 4x. Then negative 4 times negative 2 is a positive or plus 8. One more of these. Again, we need to solve for y. So let's move the 3x to the right. Those cancel out. We're left with 2y. And I have negative 3x minus 8. Lastly, I'm going to divide out the 2. So y is equal to negative 3/2 x. And 8 over 2 reduces to 4. The slope here is negative 3/2. But it's asking for the equation of a line that is perpendicular. So what is the perpendicular slope that we're going to use? So we're going to change it from negative to positive and then flip the fraction. So it's going to become a positive 2/3. All right, so y minus y1 equals m times x minus x1. We have one set of double negatives here. So we're going to change that to a plus. Then we're going to distribute, multiply at 2/3 times everything in parentheses. 2/3 times 4 is going to give me 8/3. And you can just put that in a calculator. Finally, last step is to add 5 to both sides. Excuse me. All right, so we have 2/3 x, and I have 8/3 plus 5. I don't want to do that by hand. So 23/3. So when you're adding and subtracting these fractions, you can use that calculator to help you with those. All right, excuse me, our last page. Company finds it can produce 15 heaters for $4,200 while producing 20 heaters for $5,500. Express the cost y as a linear function of the number of heaters x. So in an ordered pair, your x is your number of heaters and your y is the cost. So we do have two ordered pairs here. 15 heaters cost $4,200 to produce, while 20 heaters cost $5,500 to produce. So what we're down to is we have 2 points. We need to find a linear function, so that means they want you to find the equation of the line that goes through those 2 points. We don't have the slope, which is what we need. So let's figure out the slope first. All right, flip over to the calculator. Let me double check. 20 minus 15. All right, so 260 is going to be our slope. So I have the slope, and it doesn't matter which point you use. Everything's positive, so I'm just going to use the first one. So I'm going to have y minus y1 equals our slope times x minus x. All right, so we don't have any double negatives, which is nice. So from there, we're going to distribute. We're going to multiply that 260. So 260x, and then 260 times negative 15 is going to give me a negative or minus 3,900. Still need to get y by itself, so I'm going to add 4,200 to both sides. Adding the 4,200 to the 3,900 because neither one of those have an x on them. So y equals 260x, and then negative 3,900 plus 4,200 gives me a positive or plus 300. And that's the answer they're looking for right there. They want that linear function. They want the equation is what they want. All right. We have a vehicle. The value, we're going to look at the value of this vehicle over a 5-year period. The original value when T equals 0 is $26,000. The salvage value after 5 years when T is equal to 5 is $1,000. Okay, so I guess we had a lot of accidents or poorly made. how much has the vehicle depreciated over the 5 years? So think about it. How much value has it lost? So it was originally worth 26,000, and at the end it was only worth $1,000. So the value that it's lost $25,000 worth of its value. So that's over a 5-year period. How do you determine how much value it's lost each year? Okay, so we're going to take the total value, divide it by the number of years. So 25,000 divided by 5 is 5,000. So it's lost $5,000 each year. Now they want a linear model, so they want the equation. They use the word model when we talk about word problems sometimes. All right, so we need two things. What is the slope? What is the rate of change? The rate of change per year. The rate of change is 5,000, but since the value is depreciating, it's decreasing, that means the slope needs to be what? It needs to be negative. We do have a point at 0, 26,000, and another point at 5, 1,000. So I'm just going to graph this and see if you can catch this. Right, time is down here. We go from 0 to 5. We start at 26,000. We have another point here. So there's something special about one of these points. Okay, well, it's only 1,000. I shouldn't go that far down. What is special about this point? That is your y-intercept. When x is 0, you find your y-intercept. Okay, so our y-intercept is at 26,000. Our equation is going to be y equals negative 5,000 x plus 26,000. But they want S for the value and T for years. So you're just going to have to change the variables, change the letters up. I would wait to do it to the end since you're used to using X and Y. And then our very last one. All right, we have the growth of the membership of a country club with linear. That means it forms a straight line from 1996 to 2000. With a membership of a 211 in 1996. Year time is always your X. So in 1996, they had 211 people, and they had a rate of growth of 521 per year. So rate of growth is our what? The rate of change. That's our slope. And since it's growth, that slope is going to be positive. All right, write an equation for the membership of this country club as a function of the number of years after 1996. So X is equal to the number of years after 1996. So what X value do we use for the year 1996? All right, if it was 1997, it would be 1 because that's 1 year after 1996. So for the actual year itself, you're going to use 0. Okay. So I pulled the data out of the word problem, and then I had to do a little bit of converting because we never used the actual year itself. So what's special about this point? Okay, that is our y-intercept. All right, so the equation is y equals 521x plus 211. The second part, use the function to estimate the membership in the year 2002. So what X value do we use for 2002? How many years after 1996 is 2002? All right, I'm going to pull up the calculator. So that's going to be 6 years. So instead of plugging in 1996, we're going to plug in 6 to the equation. Flip over to the calculator. So 3337 is what the membership is. And that is it for section 1.4.